Hello friends, this video on structure of atom part 14 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 13. Now let's talk about the particle nature of electromagnetic radiations. In particle nature, I'll talk about the variation of heat capacity as a function of temperature. We'll talk about the nature of emission, the black body radiation. We'll talk about the photoelectric effect where the electrons are ejected from the metal surface. And we'll talk about the line spectra, especially with hydrogen. We'll talk about all these, which proves that the electromagnetic radiations has particle nature. Till now, what we have proved? We have proved that they are wavy nature. They are like waves. Now we'll prove that they are like particles. So let's talk about the variation of heat capacity as a function of temperature. And the black body radiation and all these things were talked about by Planck in 1900. What we can do is to experiment this. If you see this iron rod, if you heat it, this becomes red. Right? If you heat it further, it emits out radiations. And first, it emits out white color radiations, and then it gives a blue color radiations. That's what you can observe if you do experimentally. If you just keep heating it, it will emit white radiations, fumes, and then it will emit blue color radiations. So what we observe this? The radiation emitted goes from lower frequency to high frequency, because my white has lower frequency and blue has higher frequency. And this is happening when the temperature is going up, right? As the temperature goes up, the frequency of this radiation changes from lower to higher. And that gives a hint that particle there, which is, on the heating, the particle is changing the behavior. And that clearly says that the electromagnetic radiations which we get has something to do with particle nature also. The black body radiations, if you see, a black body is what? Black body is nothing but an ideal body which emits and absorbs all frequency. They are called black body. And we have seen that with experiments at a given temperature, the intensity of radiation emitted increase and then decrease with a decrease of wavelength and reaches the maximum value. And again, for example, you start from here, right? The temperature is constant, you keep decreasing your wavelength. You will find that your intensity will reach a maximum value. Then again, it will shoot back, go down. Same thing, you start from here, you keep decreasing the wavelength, the intensity will go maximum and again go down. These, if you see, right, as the temperature, based on temperature, the intensity is changing, right? So temperature and wavelength also. Temperature, wavelength, intensity are all linked actually. And then the Planck, he gave the name quantum to the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. This is the Planck who gave this name, the quantum. Quantum is the name, the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. And the energy of quantum radiation is proportional to the frequency. And the formula is E is equal to h mu, where mu is the frequency of the radiation. And this constant h is nothing but the Planck's constant, and the value is 6.626 × 10⁻34 joule second. We'll be using this. Please note the unit joule second. So these experiments, the black body radiations, and the fact that based on temperature, the radiation changes from higher frequency to low frequency, and those kind of stuffs, that clearly shows that it has something to do with the particle nature. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.